Okay. Alright. Now, yesterday we talked about operations on functions, and we talked about adding, subtracting, multiplying, and dividing. And one of the main things that is new is actually the notation. And we talked about that yesterday. Which if you go right down here, if you look right down here, when you're going to add two functions, many times you'll see it like this right here. Let me zoom in on this just a little bit. Okay, as I was saying, if you're going to add two functions, a lot of times you'll see it written like this, f plus g of x. But that just means take the two functions and add them together, f of x plus g of x. And when you add or subtract, you combine like terms. Except when you subtract, you have to be careful because whatever function you're subtracting, you have to distribute the negative, okay, and change the signs of that second function. Then multiplying, it's the same thing. F times g of x is f of x times g of x. And then f over g of x, or f divided by g of x, is the same as f of x over g of x. And we talked about yesterday that you need to specify what in the domain, what numbers x could be that would make the denominator 0. Because the denominator cannot be 0. So that's called restrictions of the domain or restricted domain. You have to tell what the denominator cannot be, or what the x value in the denominator cannot be. Such as this one, you have negative x plus 5 in the denominator. X cannot be 5, because if x were 5, that would make the denominator 0, which is undefined. So x is all real numbers except 5, so you have to specify that. Okay, then yesterday we did some examples. And we got to the multiplying and dividing, and we did, this would be example 2a. If you want to, let's put that over here. This is example 2a. Alright, then we can scroll down. And then here's what we're asked to do. F times g of x. So we did f of x times g of x. Okay, then f divided by g of x. Well, that's f of x divided by g of x. We're going to be doing the same thing on 2b. So here's 2b right here. So again, I'm going to go ahead and write it over here again. We're going to be doing f times g of x. And then we're doing f over g, or f divided by g of x. Okay? So this would be example 2b. Alright, so we want to do f times g of x, which is f of x, I'm going to rewrite it like this, times g of x. Whoops. Excuse me for just a second. Still not good and adjusted to using this pen yet. Alright, f of x times g of x. Alright, so f of x is x squared minus 7x plus 2. So we have x squared minus 7x plus 2. Put that in parentheses because we're multiplying. And then g of x is x plus 4. So we're multiplying these two together. So that means we've got to distribute. We've got to multiply x squared times x and 4. We got to multiply negative 7x times x and 4, and 2 times x and 4. Okay? So you've got to be careful. So x squared times x would be x cubed. X squared times 4 would be positive 4x squared. Negative 7x times x would be negative 7x squared. Negative 7x times 4 would be negative 28x. 2 times x would be a positive 2x. And then 2 times 4 would be a positive 8. Okay? Then we combine like terms. Okay, so we only have one x cubed term, which is just x cubed. Okay, then we have a 4x squared. Hold on a second. That's bugging me because it's too close. Okay, x cubed. Okay, then we have 4x squared and a negative 7x squared. What would that be? 4x squared minus 7x squared. Negative 3x squared. Okay, then we have a negative 28x and a positive 2x. What would that be when you combine them? Negative 26x, good. And then we just have the 8 by itself. Plus was kind of crooked. Okay. Alright, so that's how you multiply. Any questions about that? Alright, now we're going to divide. We're going to do f divided by g of x, or f over g of x, which is f of x divided by g of x. So we have x squared minus 7x plus 2 over x plus 4. Now, if we had an x plus 4 in the numerator, we could cancel those out. So you always want to check and see if the numerator can be factored, especially when you have a linear binomial down here. But can we factor x squared minus 7x plus 2? That would be product and sum. Are there two numbers that multiply to give 2 and combine to give negative 7? So it's not factorable. So we're just going to leave it like that right there. So that's our answer. However, we've got to tell what would make this denominator, what x value would make the denominator 0. Well, you can probably look at it and tell, hopefully. But if not, just go out to the side and do x plus 4 cannot be 0. Then solve it like you would an equation. I guess this would be a non-equation. So subtract 4 from both sides, so x cannot be negative 4. So that would need to go as part of the answer. So that's what it's talking about when in the directions. Right here it said indicate any. Whoop. Went to the next page, didn't it? Oh, it's kind of weird. Kind of slow too. Okay, right here, where it says indicate any restrictions in the domain or range. Well, right now we don't have any on the range. That's what we're talking about. What x value would make the denominator 0. Okay. Alright, any questions about those problems? Okay, so you think you can do some on your own now, if you're asked to? Okay. Alright, let me stop this.